If L, M, N are three numbers in geometric progression, prove that the first term of an AP whose Lth, Mth and Nth terms are in HP is to the common difference is ratio m plus 1 to 1. So we are given that there are three numbers in geometric progression. So what we can write is that m square is equal to L times n, because m is the geometric mean of L and n. Now we are also given that the Lth term, mth term and nth term of an AP, they are in HP. So let the AP have the first term as A and the common difference as D. Then the terms can be written as A plus L minus 1 times D, A plus M minus 1 times D, and A plus N minus 1 times D. Now we are given that these three terms are in harmonic progression. So we know that the middle term is the harmonic mean of these two terms. So if we have three terms A, B, C, then if B is the harmonic mean, we write that term as B is equal to 2 times AC divided by A plus C. Similarly, we can write A plus M minus 1 times D is equal to 2 times A plus L minus 1D times A plus N minus 1D divided by A plus L minus 1D plus A plus N minus 1D. Right? Now, if we bring the denominator to the left hand side, we get A plus M minus 1 times D multiplied by A plus A is 2A, L minus 1 plus N minus 1 is L plus N minus 2 times D. Right? And our right hand side, if we open up the brackets, it becomes 2 times A square plus L plus N minus 2, L plus N minus 2 times AD plus L minus 1 times N minus 1 D square. Right? Now we open the bracket on this side also. So what we get is 2A square plus L plus N minus 2 plus 2M, that is 2 times M minus 1 will be 2M minus 2 times AD plus M minus 1 times L plus N minus 2 times D square. Right? M minus 1 plus L minus times L plus N minus 2 times D square. This is equal to 2A square plus 2 times L plus N minus 2 times AD plus, if you multiply this, this becomes Ln minus L minus N plus 1 D square. Now we can see that this 2A square and this 2A square will cancel each other if we subtract 2A square from both the sides. Now we will try to collect all the terms involving AD on the left hand side and d square on the right hand side. So this becomes AD times L plus, so you have AD times L plus N and this minus 2 and minus 2 becomes minus 4, right? L plus N minus 4 plus 2m. L plus N minus 4 plus 2m, and now we bring this to this side. So this is minus 2L minus 2n, and 2 times minus 2 is minus 4, but this side it will become plus 4, right? So we have handled this term and this term. Now this is equal to d square times, you have ln minus L minus N plus 1 minus, no, you have this one is 2 times here, right? So we have forgotten 2 here because this 2 will be multiplied to this 2 also. So let me correct it again. This will be 2 times. So you have 2 ln minus 2l minus 2n plus 2 minus ml minus mn plus 2m plus L plus N minus 2. Now this d and 1 power will cancel if we divide both sides by d. So we have a times 2m minus L minus n, right? And this minus 4 and plus 4 will cancel. So this is what we have on the left hand side. On the right hand side you have d times, I can see 2m minus 2l plus l is minus l minus 2n plus n is minus n, right? So I have handled this, I have handled this, I have handled this. So 2 and minus 2 will cancel. Now you are left with plus 2 ln, so this is also handled now, minus ml and minus mn. Right? Now this can be written as d times 2m minus L minus n. But what about 2ln? Right? We know that m, l, n are in geometric progression, so we know that ln is equal to m square. So we will write this as plus 2 times m square minus ml minus mn. Now this is easy to factorize. You have d times 2m minus l minus n. I can take m as a common factor out, and you will get 2m minus L minus n, right? So you have So now you can see that 2m minus l minus n over here also. So this can be written as d times 2m minus l minus n times m plus 1. So therefore what will be the ratio of d is to a? D is to a, or sorry, a is to d is going to be equal to m plus 1, because this 2m minus l minus n will cancel over here, and this is what we had to prove, that the first term to the common difference is actually equal to m plus 1 is to 1. So this is how we can do problem number 17. Now let us look at problem number 18. If the sum of n terms of a series be a plus bn plus cn square, find the nth term and the nature of the series. Now this is actually a very easy problem. We are given that the sum of n terms Sn is a plus bn plus cn square. Now we know that this is actually equal to sum of n minus 1 terms plus an, and this is what we have to find. We have to find what is the nth term. So we can find what is Sn minus 1 using this formula again. This is going to be a plus b times n minus 1 plus c times n minus 1 square, and therefore an is going to be Sn times Sn minus 1, which is going to be a minus a is 0, b n minus, so this is going to be b plus c times n square minus n minus 1 square. So if you use the a square minus b square formula, you are going to get c times n minus n minus 1 is going to be 1 times n plus n plus 1 is going to be 2n minus 1. So this is equal to b plus c times 2n minus 1, and I can write this as b minus c plus 2 times n c, and this is my nth term. Now what is the nature of this series? The nature of this series is that it is a arithmetic progression. Now how can I say that this is an arithmetic progression? I can write this same expression as b minus c plus n minus 1 times 2c. Now you can see that I want to get 2nc here, but if I have done n minus 1 2c, I am getting minus 2c. How to get minus c here? If I simply make it b plus c. Now this expression now is exactly same as this expression. So this is my first term, b plus c is my first term, and my common difference is 2c. So I know that this is a arithmetic progression. Find the sum of n terms of the series whose nth term is given here. So we know that nth term can be written as 4n cube minus 6n square plus 4n and minus 1, right? So we have 4n cube minus 6n square plus 4n minus 1. So what is Sn going to be? Sum of n terms is going to be 4 times sigma of n cube minus 6 times sigma of n square plus 4 times sigma of n minus sigma 1 n times. So this is going to be Sn is, what is sigma n cube? It is going to be 4 times n square n plus 1 square divided by 4. So we see that 4 cancels. Similarly, what is sigma n square? It is n times n plus 1 times 2n plus 1 divided by 6. So here also 6 cancels, plus 4 times n times n plus 1 divided by 2. So this will be 2 here minus n. So what we have here is, now you can see that I can take n times n plus 1 common up till this term. So if I do that, I get n times n plus 1. Now this term will be n times n plus 1, or let me write it as n square plus n. Okay, so this term will be n square plus n. What about this term? This term will be minus 2n plus 1, so this will be minus 2n minus 1, and this one will be plus 2 minus n. Okay, remember we have minus 1 minus n over here, and this simplifies to n times n plus 1 times n square minus n plus 1 minus n. Now if I look these two expressions, I can take n as the common factor out, so Sn can be written as n times n plus 1 n square minus n plus 1 minus 1. Now what is n plus 1 n square minus n plus 1? It is same as a plus b times a square minus ab plus b square. So this expression is actually a cube plus b cube, which is n cube plus 1. So Sn is equal to n times n cube plus 1 minus 1, and therefore you are left with n to the power 4, and this is what your final answer is going to be.